Okay, so now we're looking at rational exponents, right? A rational exponent just means a fraction for an exponent. That's what rational is. Rational means anything that can be written as a fraction, right? We kind of talked about that way back in Unit 1. Okay, so if I can write it as a fraction, okay, then that would be considered a rational exponent. So what a rational exponent is a radical, okay? So the denominator here on my rational exponent is the root of the radical, right? So notice that those two things right there match. So it's the root of the radical, right? And then this, of course, is still the base. We talked about that when we did exponents, right? So this is the base as well as this is the base. Okay, so I can convert both directions. It just depends on what I need, right? So use radical notation. The great thing is they often tell me what I need. Use radical notation. So they're telling me to take this rational and change it into a radical. Radical meaning it needs a radical sign, right? So the bottom part here is the root. So this here is going to be a square root, okay, of 4, right? And then the square root of 4 is just 2. So then I can simplify it. So each one of those would do the same thing, right? So I would rewrite this. This would be the cubed root of 64, okay, because the bottom part is my root, right? And then I could take that and break that down, 8 and 2 and 4 and 2 and 4 and 2 and 2. All right, some of you guys already know the cubed root of 64. That's fine. You don't have to do the factor tree every time if you already know it. Okay, but if you don't, I'm looking for groups of 3. There's 1. There's 2. Remember, you take out every group of 3 and they multiply together, so I end up with 2 times 2 outside, which is just 4. Okay, same thing here, right? So I would get the 4th root of x. Okay, there's only 1, and I need groups of 4, so there's nothing I can simplify. It does say simplify if possible, which means it's not always possible. Okay, with these, be very, very careful. Remember, if the negative is not in parentheses, it is not included in the radical, it would go out front. Okay, so negative 9 to the 1/2. The only thing being raised to the 1/2 is the 9 itself. So the negative is out front, and I would get the square root of 9. Negative stays out front. Square root of 9 is 3. Okay, that is definitely different than this. Negative 9 to the 1/2. Now the negative is in parentheses, which means it would go in the radical, right, with that. And then I've got a negative under an even root, which would be no solution. So be very careful with those. Okay, those are very different, right? Here, the half only applies to the 9. Here, it applies to the entire 9, negative 9. Okay, so same thing here. I've got parentheses, so that means that it is the 4th root of all that stuff, which I would then take and break down. 81, 9 and 9, 3 and 3, 3 and 3, groups of 4. Right, so I get a 3 on the outside out of 8, right? I can get 2 groups of 8, or 2 groups of 4 out of 8, sorry. So 4 goes into 8 twice, so x squared, nothing left over. Okay, so same thing on those on your owns, right? So this would be the cubed root of 27, which is just 3. Okay, this would be negative square root of 64, right? The negative is out front because it's not in parentheses, so that's just negative 8 as an answer. This would be the cubed root of 125, x to the 9th, right? 125. Okay, we've broken this one down a few times, but in case you don't remember, right, there it is. So I've got 5, and then 3 goes into 9 3 times. I can get 3 groups of 3 out of 9. Sorry, you couldn't see any of that, right? So I took the 125, I broke it down, 5, 5, and 5. Well, 5 and 25, and then the 25 breaks into 5 and 5. So I get 1 group of 3 that comes out, and 3 goes into 9 3 times. Okay, so that's basically what those look like. So now here is the bigger one. This is the actual one. This is the nth root theorem, or nth root rule. Let's go with the nth root rule. Right, so a raised to the m over n. Okay, so now we're going to look at stuff that has an m on top. We were doing the same thing up here, only all the ones we looked at only had a 1. Okay, this top part here is my exponent. So the bottom is still the root. Alright, it's still this number right here. The top part is my exponent. And I always think about the fact that roots are underneath, right, like a tree, right? If I had this cute little tree here, it's my tree, I would have roots down here, right? Roots are on the bottom. Okay, so I get roots down at the bottom. So the root is on the bottom of the fraction. The exponent hangs up top. Okay, that exponent can go underneath the radical or outside. It doesn't really matter. I'm going to do this most of the time because if I can break down a smaller number and then raise it to an exponent, it makes my life easier than trying to raise it to an exponent and then break it down. Okay, so for instance, first of all, use radical notation. So again, they tell me change it to a radical. Here we go. The bottom part is my root, so this is a square root The 4 is my base. The top part here is my exponent, so it's to the third power. Okay, and again, I'm going to go outside because I already know the square root of 4, which is 2. And then 2 to the third power makes 8. Make sure you do them both. A lot of people do this, and then they lose that cube after they've already done this part. So be careful. Still the same rule applies. That negative is out front. 4th root of 16 to the third power. All right, the negative is out front. Okay, the 4th root of 16 would be 2. If you need to, break it down. 4 and 2, 2 and 2, 1, 2, 3, 4. Okay, so I get negative out front, 2 to the third power. 2 to the third power is 8, so I get negative 8. That's it. That's all there is to it. All right, so break each one of these down. Here, the negative goes inside because it was inside the parentheses. Now watch what happens. Inside the parentheses, inside the radical, right, the cubed root of negative 27 is negative 3. Break it down in a factor tree if you need to. Okay, but when I come from here to here, it is still in parentheses. If you need to, put it in parentheses here. All right, because it's still in parentheses. Okay, and then negative 3 to the second power is positive 9. So you have to be careful with that. It's in parentheses, it goes in the radical, and it stays in parentheses when we do our exponent. Okay, if it's a fraction, you do the same thing. Square root of 1 over 9 to the third power. All right, remember, anytime you have a fraction, we can split that thing apart. We talked about this in 10.3. I can split it apart. Square root of 1 is just 1. Square root of 9 is 3. Still to the third power. 1 cubed is 1, and 3 cubed is 27. Alright, just work through it piece by piece. Same thing on that last one, negative in parentheses. So here we go. We should have the cubed root, base, exponent. Okay, negative in parentheses, negative in the radical. Cubed root of negative 8 is negative 2, alright, because that breaks into 2, so I would get negative 2 squared, which is positive 4. Okay, so now the other direction, this says use rational exponents to simplify. Okay, so use rational exponents. So it says change it to a fraction for an exponent. That's what it's telling me to do. Use rational exponents. So instead, right, because I can't get a group of 8 out of 4. Okay, but I can reduce this a little, so I'm going to convert it. So this is my root, which is the denominator of the fraction, and this is the numerator of the fraction. All right, so I get x to the 4 over 8, because roots go on bottom. And then I can reduce that. Okay, and that's it. That's all you're really looking at. If it doesn't say to write it as a single radical, you don't really have to. You can leave it just like that. Okay, do be careful with these though, because you are trying to simplify, right? So if I convert this 25 to the 3/6, right, exponent over root, which would be 25 to the 1/2. Okay, 25 to the 1/2, that becomes a square root, right? Because the square root, the root is 2, and a 1 is an exponent, so then the square root of 25 is 5. So since it was an actual number that I could do something with, I did convert it back to a radical so I could finish simplifying. Here, I can convert it back, but it's just going to give me that. I can't go any further, so I don't really have to worry about that. But since this is going to actually change, I have to. Okay, so same thing here, right? The easiest way is just to give this denominator to each one. So r to the 2/4, s to the 6/4. Okay? Reduce each one of those, r to the 1/2, s to the 3/2. And that's it. If I put it underneath a square root, it's not really going to do anything, so I might as well just leave it like that. Okay, one more of those. You should hit pause and see if you can do it, but here we go. 27, 2/6, 27, 1/3. This is a number I can do something with. Cubed root 27 is equal to 3. Okay, so that is it for those nice easy ones. So now let's look at all this nasty stuff that has like negative exponents to it and stuff like that. Okay, so don't forget that negative exponents, just take the whole thing and drop it to the bottom. That's from Unit 7. Okay, so if you need more detail about how the negative exponents work, go back to Unit 7 and watch the negative exponent video. Okay, so then everything else, right, then you just do the same way. So negative exponent takes and drops the whole entire thing to the bottom. Okay? Never, ever, ever flip your exponent. You just drop the whole thing to the bottom and your exponent is now positive. That's what a negative exponent does. Takes the whole thing to the bottom. Takes the whole thing to the bottom. So then from there, you're still just working this. So I'm going to convert it. Right? 1 over, this is going to be 2, right? 8 and 2, 4 and 2, 2 and 2. I know I kind of made a mess, but there's 1, 2, 3 of those, or 4 of those. So I get 2. Don't forget about that third power out there. And then 1 over 8. Okay, so the only thing that was really even different is we made that first step where we dropped it down, and then all this stuff just happens in the bottom. We just keep that 1 across the top the whole entire time. That's it. Alright, so same thing here. Here we go. 1 over negative 81 to the positive 1/4. Notice I did not change the sign, because the only thing that changes signs is the exponent itself when it drops. Okay, so that would be 1 over the 4th root of negative 81. That is a negative under an even root. That is a no solution. Okay, if you have parentheses with a fraction and a negative exponent, then they both move. Right, so instead of the whole thing just dropping to the bottom, the top goes to the bottom, bottom goes to the top. So that means this is going to become 4 over 1 to the positive 3/2, right, which is just a 4 to the 3/2, which would be the square root of 4 to the 3rd power, which would be 2 to the 3rd power, which is 8. Okay, convert, flip. Alright, convert, bottom is the root, top is the exponent. Simplify the radical, raise it to the exponent. Here we go, let's see another one. 1 over negative 8 to the positive 2/3. Drop it to the bottom. Convert. Simplify the radical. Do the exponent. Same thing every time. Here we go again. Okay, drop it to the bottom. Convert. Simplify the radical, raise it to the exponent. Right? And this is a perfect example. Yes, I could technically do the cube first, but nobody wants to do 25 to the 3rd power and then break that down. It's a whole lot harder. Okay? Drop it to the bottom. Make that positive. Convert it. Simplify the radical. Okay, do the exponent. Fraction, flip it. Make it a positive exponent. Convert it. Simplify the radical. Right, so same sort of thing over and over and over and over again, right? So, now the next part. So here's the properties of exponents that we learned in Unit 7. Okay, we just rewrote them right here. We've already done all of these. Multiplying bases, you add exponents. Dividing bases, you subtract exponents. A power raised to another power, you multiply exponents. Okay, a power on a product, you distribute it. That's not really the right word, but that's the way we all kind of think of it. Okay, it's going to go to a distributing kind of thing, so it's going to be an exponent on each one of them. Right, same thing with the quotient. The exponent goes to each piece of it. Okay, including numbers. If there's numbers in here, make sure it goes to the number as well. And then everything to the 0 power is equal to 1. So here's this last little part, right? So if I'm multiplying bases, I'm adding exponents. Just because they're fractions does not make that any different. Right? 1/3 plus 5/3 makes 6/3. And then I just reduce that. That's it. Okay? So multiplying bases, x 1/2, x times 1, x to the 1/3, multiplying bases, you add exponents. Okay, in order to add fractions, I do need a common denominator, or you can use your calculator. I really don't care either way. Okay, I'm not going to teach you to do it with your calculator, but if you know how, you can. 3/6, 2/6, 5/6. Alright, just getting a common denominator. If you're not sure how to do that, go back to Unit 1 and watch the video on adding fractions. Okay? There's a whole video on adding fractions. So if you're not sure how to add fractions, go back to Unit 1. Okay? Same thing here. Okay? Dividing bases. Subtract the exponents. So I'm going to get rid of the smallest, subtract that exponent from the largest. Notice I do not cross out sevens. Just like whenever I'm doing x over x, I don't cross out the x's, right? Because this is different exponent, so we are going to subtract the exponent. Since everything crosses out on top, we put a 1 to hold that spot. And 4/3 minus 1/3 gives me 3/3. Okay, so that's 1 over 7 to the first power, which is just 1 over 7. Power to a power, make sure you distribute it to everything. So 2 to the 5th power, right? X to the, a power and a power you multiply. So 2/5 times 5, remember they got that imaginary 1 underneath. 2 times 5 is 10, and 5 times 1 makes 5. Do the same thing for the y. Negative 1 times 5 is negative 5, and 3 times 1 is 3. Okay, don't distribute that to the bottom. The bottom's not in parentheses, so don't distribute it there. Okay, so now I'm going to simplify all that stuff as much as possible. 2 to the 5th power is 32. Okay, 10 divided by 5 is 2. I'm going to take this whole negative exponent and drop it to the bottom. Alright, I don't want the negative exponent up there, so I drop the whole thing to the bottom and make it positive. Alright, so now I can add these two. I've got x squared on the bottom. Yes, we'll take care of those in a second. And then y to the first times y to the 5/3. I need to, since I'm multiplying, I need to add the exponents. Okay, I'll just kind of do this off to the side. So I'm going to put my whole number under 1. I'm going to get my common denominator. 3/3 plus 5/3 makes 8/3. Alright, so that gives me y to the 8/3 power. Okay, and then the very last thing, remember you can only have one of each type of variable, so I've got to go see what can simplify. I do have an x squared and an x squared, so if I get rid of that and subtract, I end up with x to the 0, so it just goes away. My final answer here is 32 over y to the 8/3. Okay, 2 on your owns there. I hope you hit pause and try them because these are a little more difficult than the ones we've been doing. Right, this is definitely the harder part of the test, I would think. Okay, so go ahead and hit pause and give those a shot, and then see if you got the same thing as me. So, I'm going to add these, which means I need a common denominator, right, which is going to be 4. So times 4 and times 5, which gives me 12 over 20 plus 5 over 20, which will give me x to the 17/20. Okay, for the second one, make sure you distribute that 4 first. Alright, so we've got 3 to the 4th power, x to the 4 over 4, because I'm multiplying, power to power and multiply, negative 8/3. Alright, don't forget there's an imaginary 1 on bottom if you need to multiply tops, bottoms. Right, on the bottom, that just stays the same. Reduce everything you can. 3 to the 4th power is 81. 4 makes x to the 1st power. I'm going to take that whole nasty negative and move it to the bottom, and it becomes positive. Okay, so on the bottom I've got x to the 4th, and then y to the 1st plus 8/3. Alright, that's an 8/3. So 1 plus 8/3. Again, I put my whole number over 1 times 3 top and bottom. Gives me 3/3 plus 8/3, which is 11/3. Alright, so I've got y to the 11/3, right, because I was just adding those exponents on top. Okay, and then very last step, right, I've got an x to the 1st and an x to the 4th, so get rid of the smallest, subtract that from the largest, and we end up with 81, x to the 3rd, y to the 11/3. Okay, so do those again a few times if you need to. They're definitely a little more challenging than the rest. Alright, so this last part, use rational exponents to write it as a single radical. So they want me to write these things as one radical. Okay, and the challenging part is that they are different roots. Alright, so when we learned the rule about multiplication, it said the roots had to be the same in order to just multiply. So I can't just do x times x and make it the square root of x squared or the 4th root of x squared. That doesn't work because the roots are different. What I'm going to do instead is use rational exponents. Again, read those instructions. It tells you what to do. It tells me to convert this. Square root of x is x to the 1/2. Okay? The 4th root of x is x to the 1/4. So I'm just converting them to a rational exponent, right? So the exponent is 1, the root is 4. The exponent is 1, the root is 2. So now if I'm multiplying bases, I add exponents. right, which means I need a common denominator. So x to the 2/4 plus 1/4 is x to the 3/4. Right, same thing for division. Change it, 1/2, 1/3. Alright, so that would be x to the 1/2 minus 1/3. Okay, I need a common denominator. X to the 3/6 minus 2/6 is x to the 1/6. Oops, except I forgot the most important part. Got to go back to that first one, okay, because the whole thing said to write it as a single radical, and I didn't do that, right? I wrote it as a single rational exponent. So I was supposed to, if I'd have read my own instructions, was go back and finish this, right? So x to the 3/4, write it as a radical, 4th root of x cubed. Okay, totally my fault, right? Single radical. Write it as a radical. Write it as a single radical. Luckily, I looked up and saw I boxed it in. Okay, so here, not x to the 1/6. Got to finish this off and convert it. So the 6th root of x to the 1st power. Okay, so try that last one. Come and see if you have the correct answer. I'm going to keep on going here. So y to the 1/3. Y to the 1/5. Alright, so then I'm just going to do it from here. So times 3, top and bottom, times 5. Top and bottom, that gives me y to the 5/15, y to the 3/15. Subtract the smaller from the larger, gives me y to the 2/15. It's in the top. We don't have to hold the spot on bottom. Remember, we don't have to put a 1 underneath. Okay, we only care about the 1 on the top. So y to the 2/15, not my final answer though. I need to write it as a single radical. So convert 15th root of y squared. Okay, so that's dealing with rational exponents. Okay, so that should cover all of 10 point, whichever one that is, 10.2 I think.